everyone, Fus Muhammad Sharaf with you. Today, actually this is the second lecture about solar desalination flashing for MED, multi-effect distillation. We intended to discover more and more about how to extract your data, how to change your inputs, how to use a signal builder, how to change your parameters at once. First of all, you have to specify your folder. Okay, you have to go here and specify your folder by your drive. Don't open your model from outside or by using desktop. Just copy your download folder in your working folder and go to your download folder. This is your model folder. Okay, and click here and sort by name and group by type. So you find it here, and this is our main model, solar desalination flashing by MED. Okay, double clicking. Okay, now we are this is our main model. Okay, we demonstrated this before. So we are now focusing on how to change your outputs. As you can see here, we have going inside. This is our main environment. We have parabolic solar field, flash evaporation tank, and bomb. This is solar field, okay, and this is water. So PTC or parabolic trough intended to give us hot water and to be flashed in flash cyclone. So we are considering flash cyclone as a steam generator, and steam should be responsible for heat, thermal power or heat input to the first effect of the MED, and so on. If you go inside, this is your model browser. You have to click here and go for model browser and check all of this. This is PTC, flash cyclone, MED. This is MED plant with its recirculating pumps, water pump for solar field, and cost consideration below. If you go for any block and double clicking here, as you can see here, these are your inputs and these are your outputs. So if you double click here, you will find your function, and these are your inputs. So you can change here, or you can add many parameters if you would like. You can change, you can copy this, you can copy it, you can use it. And this is function name, and these are your inputs. So you can add more inputs by semicolon and add more inputs if you would like. Okay, you can add more inputs, but be sure that any input should be maintained or manipulated in your design code. Okay, let's go and see. First of all, you can run your model in fixed point iteration by clicking here outside and double clicking. So we have here your inputs parameter. These are your inputs. We have productivity, ambient temperature, solar radiation, and outlet temperature from parabolic solar field. We can change these limitations. Just click here, okay, and right click and go into the mask, edit mask, or Control M, edit mask. So you can go here inside and click on parameters. You can use this, you change these documentations if you would like, and unique parameters. You will find your parameters are here stored here. So you can change parameter type inputs. Is it edit or checkbox or radio button or whatever, slider, dial, it's up to you. For example, this is my total plant productivity. Be sure that this is the callback name, this MED. If you go inside here, go inside, you will find MAD. So if you change any change here, should be depending on this block, because this is MAD, it has the same name, okay? And you can for slider you can assign maximum and limitations, or the range. This is your range. So I suppose I need the range up to 10,000, okay, 10,000 meter cube per day, okay? And you can input the value. You can input the value here or outside. And the same for the rest. For ambient temperature, you can change the limitation. Solar radiation, maybe 1,000 up to 200 watt per meter square, no more than this. And outlet temperature, solar field temperature, I think up to 250 degrees Celsius is quite normal. No more than this for solar field with water, working fluid. Saving your model. And if you go outside here, let's go outside, double clicking, you realize the changes. As you can see, productivity, the change, the range has changed, ambient temperature, and limitation of the solar field temperature, solar radiation, and so on. So we can control some inputs like this. Let's hit run and see. If you hit run, you can control sub blocks. Double clicking here, and you can see here, this is your MAD. So we have to change seawater temperature, brine blow down temperature, okay, seawater salinity, brine blow down salinity ratio, and some design aspects, number of effects, inner tube diameters, and so on. Efficiency of your pumps, for example, okay. This is condenser effectiveness, pumps efficiencies, and so on. So if any change here should be effect on the change inside MAD. For example, let's go here, seawater temperature, okay. So if you would like to change the limitation, you have to go outside here, double clicking, and go inside again to the MAD, and pop out this menu, and you will realize this one. So changing here temperature will affect on sea temperature, brine blow down temperature, or salinity, as you can see here, brine salinity. If you would like to inspect more, you just right click here, going to the mask and edit mask for MAD, edit mask for MAD, going inside again, and you will side, and you're going to the parameter, and you will realize the connection between parameters. TCE, as you can see here, with limitation or the range from 1 degree Celsius up to 50, is responsible for this block. And TB is brine blow down temperature. SB is salinity of the brine, you will find it here. Salinity of the feed, you will find it here. And efficiency of end condenser or effectiveness, you will find it here, and so on. So you can control inputs by using. Let's hit run and see. This is our run. Just in zero time domain, we clicking our run. Zero time domain, there's no changes. Okay, so these are our results. Okay, let's go here outside. You can realize your results output here. That's the first one. And the second method, if you go inside, for example, for MAD, you will realize your results here. I'm sorry, going up. Okay, in this display block, so you can extract your data from here. Okay. The second method is to use signal builder. Okay. Suppose I need to discover this. You have to click here on this signal. Suppose I need to discover the result or export my results to data inspector. So you have to click here and click to stream selected signals to data inspector. You can select this option. So realize there is a change, a small square here. So this small square is telling us that this signal condensed pressure will be sent to the data inspector. And the same for condensed enthalpy. Just click on the signal, highlighted it, and going here and click here. So enthalpy of the condensed steam will be sent to the data inspector. Okay. What is the reason for data inspector? You can change the time. So I can change the time, write infinity. Okay, saving. Okay, and going here and double clicking on MED. Okay, and going inside again for MED, and we will make some changes. Hit run again, hit run. Okay, and going here for the MED menu. Let's try to change. I'm trying to change. I have to wait a little bit. Okay, let's try, for example, seawater temperature. Okay, I am increasing, moving your keyboard arrows right or left. Okay, there is no change on MED. Let's go for brine. I think brine blue down will change. Yes, brine blue down will change brine profile and temperature. Let's go down for temperature. I'm sorry, let's go up a little bit, and let's try to, I'm trying to increase brine blue down temperature. As you can see here, it has an effect on area or gain ratio or brine temperature profile. That's decreasing. I think 35 is quite normal. Okay, 35 is quite normal. Okay, and seawater temperature, I am trying to decrease it. Decrease seawater temperature, yes. Okay, it has the same effect. Okay, so we can change your parameters. All of this under the time domain. As you can see here, this is the time domain changing. Okay, let's say to stop again. Okay, if you going here, if you intended to go, this is your exergetic results, exergy stream, inlet steam exergy, outlet steam exergy, exergy of the feed, exergy of the distillate, exergy of the brine. Okay, and you can realize cost analysis. Sure, you can realize the changes in the cost. So going here in data inspector, and let's trying to discover some results. Okay, as you can see here, and you can compare runs. This is the first run at 0 time domain, and this is the second run. Clicking here, this is the changing in specific power consumption, MED hourly cost, but you can we have to change the format. I will make it from up to 35, so you can realize the change from 30 up to 35 or 32. Okay, this is a change in hourly cost for MED. From format, you can format the outputs, collect the same for this is evaporator hourly costs, pumping cost, and many parameters you can extract here: performance ratio, change, varying, total pumping powers, and solar field area. There's slightly change in solar field area, so you can discover this one. The dryness fraction. Let's go for the dryness fraction. I think there's no massive effect on the dryness fraction. Flash tank. Okay. So we have some outputs to withdraw. Suppose I need to change all parameters at once. So we have another option that we can use a signal builder. First of all, save your model, save as. Okay, save as. Let it be dynamic version. Let it be dynamic version. Okay. So I saved my model for save as. And now I'm trying to not to use this menu for MED or this menu for the whole plant. So I will try to change some parameters at once. For example, let's go from the easy one. Let's go here, going to the signal libraries, going for sources, okay, and let's go for a signal builder block. Drag and drop, okay. This is our signal builder block. So I will try to change the inputs automatically without using my manual effects by moving cursors of the keyboard left or right, or let's go for automatic changes. Suppose I need to change MED productivity and solar radiation, okay, and let's go for or MED and outlet temperature from the solar field. Let's go for this post parameters as an example. So I know that these two parameters are inside here. As you can see here, this is outlet collector temperature, and this is productivity, plant productivity, okay. As you can see here, this is your plant productivity. So I will control X and put it here, control V, and this one control X and put it here, control V, going to signal sinks and try to terminate this signal. There is no need for this. I will use terminator, control I to swap, terminator, and connect. So I terminate the block of MED and outlet temperature, so there is no effect from here. If you change the productivity from here or outlet temperature, there is no effect because we terminated this this effect. So let's go for data inspector by signal builder. So I will go for source again using inlet. This is the input one. This input one for MED, and I will rename it as MED, okay, meter cube per day, okay, and I will drag another one, paste it here, okay, and control I to swap it, and I will rename it as T collector out in degrees Celsius. This is outlet collector temperature. So if you go outside here to the mother block, let's go, you realize there is two inputs to the mother blocks. The first one is MED because it holds the tag number 1, and this is outlet temperature holding the tag number 2. So let's go here and right click. You can right click, going to the mask and edit mask, changing this to with ports, apply in order to show where the inputs signal is going for, MED and outlet collector temperature. Now we are going to create the signals. Suppose I need the signal for 5 hours or 10 hours, 5 hours, that's enough. So I will set my simulation time into 5 hours as an example. You can write here 5 hours, or going here and going to the solver. My time is from beginning from hour number 1 up to hour number 5, hitting apply and OK. And let's go for, therefore we have 4 hours. Going to the signal, going to access change time, we are from 1 up to 5 and hit OK. So we have 5. We can add another signal. Okay. So we have 2 signals. The signal number 1, I will rename it as MD, meter cube per day. Okay. And signal number 2 is outlet collector temperature in degrees Celsius. So now we can control our let's begin from our number 1. As you realize this in this is your time, and this is this is your value. So at our number 1, the value is, for example, 500 meter cube per day. Okay, so this is 500. And our number 2, let's go click here again, hold shift and create a signal, a port or node. Hold shift, I'm holding shift and going to the signal node by node, as you can see here. Okay, and let's go for this one. This is our number 2. Our results should be, our input should be 1000 meter cube per day. Okay, I have to do this one. And this one, I'm sorry, this is should be 2. Oh, I'm sorry, this is 1.5 and this is 2. And this is 2. Okay, let's go here. This is 2.5. Okay, I will remove it. I'm sorry. Let's go back again. Let it be 2.5, and output should be 5000 meter cube per day. And we have here for this one at times 3 we have 10,000 meter cube per day, and at this one I think this is 3.5. At 3.5 we have here for example 20,000 meter cube per day, and at hour 4 we have 50,000 meter cube per day. I have to delete this one. And we have here at 4.5 we have 100,000. Okay, and at this one at 5 we have 400,000. So this is our productivity changing nodes. So as you can see, let's go for this one. You can click on the node, okay, and click delete, so you can remove the node. Let's go for temperature changes. This is outlet solar field temperature. Suppose at our number 1 temperature should be 100 degrees Celsius, and let's create another node at point 2. Just click, hold shift and click here, hold shift and click here. Okay, so we have these nodes or points. At our number 2, let's go for 110. Node number 3, it should be 120. 4. We can change it at 140, for example, and last one should be 160 degrees Celsius. So we have the variation of outlet solar field temperature and plant productivity. Just an example about how to change. You can change many parameters. You can change many parameters. Let's saving and close this one. And now we are trying to, sorry, I have to wait. Okay, we have to connect productivity and temperature. And you can group this one by operative conditions. Let's go here, formatting, font style, going up to 20. Okay, bold. Okay, So you can add more. Let's go from another signal from inside. Let's go for MED. I'm going for MED. I will try to change brine blow down temperature. Let's go for brine blow down. This is your brine blow down temperature, TB. So I will Control X and copy it here, and going for the same terminator. Okay, and connect this one, and going for source. Let's go for the source, adding a new one, and I will name it here as TBN degrees Celsius. Okay, saving. So I have to go outside the block. Let's go outside. You realize it, this one. So this one is brine blow down temperature, so I need to add another one. Another source from here. And Control I to swipe it and connect it. Okay, and you can name it TBN degrees Celsius. Okay, so if you go outside here, you realize there's another one. We can add another signal. We have to add another signal. Going to the signal, add another one step, for example, and we will rename it as brine blow down temperature, TBN degrees Celsius. And I think we can change it from 35. I will remove this one up to 40. I'm sorry, at 3 we can 40 degrees Celsius. Okay, and down again for 35. Just an example, and we will realize this one. Okay, saving your model. Okay, and we have our inputs as a signals, and we can connect this. Okay, save your model, and let's hit run and see our results on Data Inspector or outside. Let's hit run. So there is a counter for the time. This time counters. We have to wait for a while. So there is no need to change by your manually. There is no manually. The system is running with respect to the time within 5 hours. Okay, it stop. So we have going here and Data Inspector. Let's go for this is a previous run. So I will. You can compare now. Specific bulk consumption. I need another one, empty one, another one. Specific bulk consumption, varying. You can add more slots from here. You can more empty slots. It's better to delete all of this and make another one, new one. Let's delete all, yes. And let's go for just 9 slots. And closing, saving. And hit run again. We have to wait. Yes, this is the time counter. We have to wait. 3.95. Okay, 5. Let's go inside and see our results. Okay, let's go for performance ratio. As you can see, performance ratio is changing with respect to depending on brine blow down temperature, steam mass flow rate, because we increased the productivity, MED area, effect by effect. I'm sorry, this is based on productivity. Okay, changes, condensed enthalpy, pressure. Let's go for costs. It's increasing the costs. Cost has increased. Total hourly costs. Because the effect of productivity and solar field. Let's go for solar field area. And this is drainage fraction. Okay, drainage fraction has increased because we increased the outlet temperature of the solar field. And let's go for flash tank height. Let's go for total mass flow rates and solar field area collector parameter. Okay, increase because we increase the load on the solar field, we increase the productivity demanded by the solar field, so there is mass of the steam has increased, followed by, or depending on the solar field, a larger area to recover the massive or overwhelming steam flow rates should be responsible for high rate of productivities. We have here more results. You can go here outside. You can go here outside and trying to inspect results. Evaporation temperature. I'll go for plots. This effective effect. So suppose you need to let's go. I'm sorry. I have to go here. Data inspector again. Suppose I need to use these figures, so you can click here, send it to a figure. Okay, sending our result to a figure, and you can make another run. Okay, and clicking on figure properties tools, and we can change our results here if you would like, the ranges, the time. Okay. Okay, I'm emphasizing, changing the background. Okay, you can change the lines, go here. Okay, and so on. You can change the caption. You can hold shift and click on all figures. Okay, and you can change the time, for example, time, and this with hours, so this is our time, and you can change Y caption if you like, and so on. You can save your figure, you can do what you would like as well. Finally, I would like to thank you very much for your interest in our model. Don't forget to like, share and subscribe. Thank you very much.